So yeah, when it comes to monitoring, we have our regular business KPIs, but we also now have some smarter approaches in terms of the Six Sigma thinking and monitoring, the process control monitoring concepts. Process control monitoring isn't about monitoring our production process. It's about monitoring any process. This is a maintenance process output. This is people's work output. So if we think in process control charts are just for processes involving machines, we've missed the whole point. This is process, any process, a manufacturing process, a maintenance process, a financial process. These are only errors, yeah? Hours lost due to breakdowns. And so this particular style of monitoring applies to anything that we can convert into a boxes and arrows flow diagram on a piece of paper. That concept will work. All right, we've got through understanding where the risks are, why the risks are there, how to address those risks, to put into place the right designed solutions, to monitor the solutions in operation, but that isn't enough. Because if we only go that far and then the competitor does the same thing as we've now done, and they'll soon catch up with us. So I cannot stop at just putting in a change. I've got to start running with this change and making things better and better and better continuously forevermore. Because if I stand still, the world will catch up and pass me. So in our solutions we're going to offer to companies in terms of wellness, I want to help them always be well, to be always at the forefront of great results. So we want to have a way of continually eliminating risk, reducing the chance of failure less and less and less as time goes by. So we've got to the point where we've got known risks and known costs. We've got strategies and techniques to address those particular problems. We want to now go into a situation where they are being used and we can in fact ensure that they are being improved. Chance reduction is a big focus. I want to prevent the need for maintenance. I don't want to have maintenance at all, if possible. At least have no failures. There are things we will do that are consequence management. I don't want to throw away my photography camera and vibration analysing equipment because they are useful when necessary. So I want to take the best of those decisions and strategies into use and make them regular practice. And I want to find ways to push the limit. Find ways to look for a smarter answer, a better result, more return on investment than we're currently doing. So we're going to take these three avenues, reducing chance of failure, ensuring plan B is there, that we spot problems before they become a breakdown and act on those smartly, but also find better answers to reduce and minimise the use of these further and further as time goes by. This will be things like better technology, better training, new process, change the process to a better one with less waste and less problems. I don't know where this will take us, but this is what we're going to include to make sure that we are always looking for better solutions. The idea here would be to intentionally ask people to, these KPIs we're getting from our monitoring, they're not fantastic KPIs. Can you suggest ways to improve our process? You and I will never know that business well enough to change that business. We're going to have to get the people in the business to challenge themselves and say, well, yeah, we've got a better idea. What do you suggest? Well, we could try this. Okay, let's do an experiment. Let's do a trial. Let's do a dummy run. Let's not risk anyone being upset if it goes wrong. So we're going to use words about experimentation and testing. But if that test actually produces better results, then suddenly, hey, this is proving to be successful. Let's test this again, make sure it is right. And if it works, we're going to make this the new way of doing things in this business. Then, of course, any real improvements, we're going to update our current quality management system. So the 3 T's, the ACE 3 T's, is where we trap the change, because the procedures that we wrote will now include the improved ways of doing things. If that means retraining and new training, well, that's what will have to be done as well. So yeah, we're not going to stand still. We don't want any company to stand still, because immediately they stop improving, then the day will come that they will now be the guys behind the forefront. And nobody wants to be there. We want to be at the leading edge of success. This slide is not actually mine. It comes from Sumitomo Chemicals in Japan, and I got this back in my visit in 2004. I asked the guys in the maintenance group there in that company to say, well, can you describe to me the way you handle problems in your business? I've got a couple of slides, and this is the first one. The second one will be coming up next. It talks about how they handle failure, and this begins up here. This is Japanese English. I have not changed any words. This was given to me by the Japanese engineer, written in English as he used those words. And I loved the choice of words. Yeah, a failure occurrence happens. Any failure, we come in, every morning there's a meeting in which they discuss the problems that happened in the last period of time. We then classify those problems into one of two possible ones: grave problems and slight problems. If there are slight problems, we investigate the cause, we work out what is necessary to address that cause, we work out what's needed to be done and record their requirements to be done. We then apply those techniques, we put the controls in place, control sheet for failure data. They actually begin measuring the changes, producing the results they want. They actually capture data to prove the change is effective. If a change is effective, it becomes a permanent improvement. Not only that, if it's a permanent improvement, it comes across to prevent reoccurrence. So they actually build their processes to prevent the repeat of that problem. If it's a grave problem, they say exterminate the grave, conquer the slight. Now, to me, they're lovely words to use. Exterminate the grave. Now, get rid of the damn thing to never come back again. To me, that's the way to think. These failures should never happen. There's no need for this. So again, when it's a grave problem, inquire the cause, investigate measures, implement the measures that we think is the right result, follow up, gather data, prove the failure is reducing, improve the strategies, make this our permanent way of doing things. The PM10 is planned maintenance activities for the next 10 years to reduce maintenance costs. So this now becomes the way they address this problem. And they're also very smart. When we find the right answer, lateral development. Take this learning laterally across the company, throughout the whole business. This one grave disaster, learn from this, and across the whole business, develop the solutions laterally across the business. They are now using strategic property number 3 across the business. So prevent, reassemble the failure. Prevent this similar failure. Take that learning. What other situations are close to this that this learning lets us prevent, and make those changes. And of course, prevention leads to a sunny, happier place. I loved their thinking. I loved the fact that this is exactly the way to think to solve problems, to prevent the need for maintenance, prevent the need for failure. We're human beings. We can become better. We can have better processes. We can design a business to produce great results and follow the design and do the right things. And that we can all do. That's what PW is all about. What are the right things that give us the right results? Let's do them, guys. Let's just create these rules we're going to follow and follow the rules. And get better all the time, get smarter. Then there was this particular one here, exterminate the grave. So they're taking that previous slide a little bit further. So the occurrence of the failure has occurred. Hey, why? They do a root cause analysis. They understand the problems, what parts failed. Oh, I love that. I'm glad I mentioned the part. You know, what is the part that failed that caused the accident to happen in the first place? Judge and expose the cause of failure. Let's find the truth, find the root cause. Implement the functional test. Come up with a solution to solve that root cause. Compare, evaluate differences between our options. Hey, that's what to do. We come down, find the real root cause, solve that cause, implement countermeasure for the drag. Drag is what drags the business now. What are the measures to prevent this trouble in future? Japanese English, bear in mind, this is the words they've chosen. Beautifully again, lateral development inside the plant. Investigate meeting of grave failure. So is this lateral improvement going to actually is it actually delivering the outcomes that we want? If we're happy with that suggestion, we then make that an order. Yes, do this change across the plant, across the business, implement the changes, monitor those and make the change permanent. Not difficult. But this is their business process. You follow this process, you will produce a better and better business all the time. And we want that. We want to have processes that solve problems, implement the change permanently, and it is always in place. So that problem never comes back again. And this technique of reliability growth cause analysis is one of the ways that we're going to be proactively looking for problems. What failure modes can affect each step, whether it's a mechanical process step, whether it's a production process step, whether it's a work process step. Yeah? This step, if it's a task, what failures can happen in this task? And the guys that do these tasks know what can go wrong. Now, we're going to use our physical failure list of potential problems that cause stress and disaster. We're going to look at human factors, lousy business processes, what physical activities and what physical issues affect the internal workings of our machines, and latency factors. Latency is human element type factors. We're going to be fairly tough on what can cause problems, because we want to build a process where they are minimised and hopefully eliminated proactively. We can do what they're suggesting here. We can wait for the accident and then use that as evidence that it's worth fixing, but gee, that's a hard way and an expensive way to repair your business. Better to be proactive and imagine what could go wrong, decide if it's a real risk for the business. If it's a real risk, act on it immediately. Fix it before it goes wrong, so we don't have to have the disasters to give us the evidence to justify making the change. Doesn't make any sense to me to let things break on purpose to prove that I actually have a problem that I now got to fix. That's reverse logic. So yeah, the RGCA is all about finding an answer well ahead of it being a problem. It'll come down again to some sort of matrix, some sort of table where we actually list cause by cause, the cost if we don't do anything about it, what the current risk is, what are we going to do, what are the controls we're going to put in place, what's the risk after the controls, and what's the cost of doing all that. So it ties back to our previous matrix we had before of the analysis of the engine valve. The valve, same sort of approach, different layout. It isn't so much the layout that matters, it's the thinking behind the analysis that matters. And of course, there's the solutions we want to put into place with some degree of confidence that if we do these things here, we're going to go from a medium risk of failure down to a low risk, and I will free up $20,000 a year by doing that. I can show this, of course, on my risk matrix as well, and actually plot these bullet points across the risk matrix and show them the actual movement in risk by applying these particular strategies. I mentioned before, Sumitomo Chemicals use a PM10 technique, or what their PM10 table is all about is they have a spreadsheet where they record all the major problems of a machine during its life. When I saw that spreadsheet in 2004, they had, 2002 it was as a matter of fact. On the spreadsheet they had 8 years of previous history, and these particular notations are the major problems this particular plant had. So there's the asset, there's a sub-assembly, break it down into the category that we know that equipment as. And these notations are the major problems by the half year that happened in this year and in this year and in that year. So at this point in time in 2002, there was a history of all the problems that they had suffered. Now, of course, they fixed those problems and put the plant back in operation again. But this PM10 is about solving these problems in the coming period of time. And what they had done on this very same table is to say, in the next 2 years, this is what we're going to do to solve these problems. So on this one table, it was a strategy to improve their business. Here are the known problems that will reoccur again because this is the result of how we had the business running. To stop these problems, we're going to do this in next year and the following year after. And by doing these, I will stop this reoccurrence. And right here is the strategy to make their company better, what they're going to do, when they're going to do it, what they're going to spend, what's involved in making that change. So their PM10 table was about this 10-year moving period of what it was in the past, what known troubles will probably reoccur again, and what we're going to do to prevent those troubles in the immediate 2 coming years. And that was always rolling forward. It's always every year it's rolling forward. So there's a rolling strategy to improve the business that never stops. And these activities to improve the business are based upon known faults that keep reoccurring. So I'm tying back my database and my history and my knowledge of my process with solutions to prevent those recurring problems. And it's right there for everybody to see. This is next year's plan. If it involves capital assets, well, the capital asset purchase goes into the capital budget. So the whole thing links back to the whole business strategy. I like that very much because it made clear why we are making the change, the sense of doing it, because here are the problems we're going to prevent in future. And to me, it makes it very clear what value maintenance brings, what value it is to run the plant well, to redesign the plant if need be. So yeah, this is something that we have as a tool to be able to begin tracking is what we're doing producing better results than what we had before. Are we stopping these problems from reoccurring? And if, as the time goes by, less and less problems happen because we have good techniques and good processes, then that's what we actually want the business to be doing.
But it takes years to see what track you're on.
You do a reliability improvement, it'll take you 12 months to 18 months to 2 years to see that come through as positive benefits that you know are going to be there forevermore.
So, but during that time, can they see anything in the plant? Or are they going to call you up and say, everything's the same?
You'll be able to see that things won't be going wrong. We expect to see this frequency of failure should be reducing. These problems should not be recurring or recurring further apart in time. So yeah, we should be able to see, it's a bit of a leap of faith as been mentioned. If we do the right things, we expect the right results. But some of these outcomes take time to show themselves. And we have to have the faith that because we've built a process to produce this output that's known to be achievable and we're designed for that, then we need the time to prove that's the output that will actually occur.
So it'd be important to make sure the client understands that.
Absolutely, yeah. That's why some of the KPIs we had before, we can KPI that the right things are being done. We can't KPI the results yet because the results aren't there. But if we know if we do the right things and KPI the right actions are being performed, then in time the results must come. So I can't give you a KPI for the final outcome that will only appear for 3 or 4, 2 years down the track or 3 years down the track. But I know if I do the right precision maintenance, run the plant in precision operation, do the right activities that lead and cause that to happen, it must come. Yeah.
You'd have to start out with something as simple as we're going to start with equipment criticality. We got to measure if we got equipment criticality.
Yeah.
I did 100 pieces of equipment, ranked them in criticality. Now we got the best. Now we got to do risk assessment on these top 10 or what.
That's right.
You measure your process down the path. At some point in time, your business KPIs are going to start improving too.
Very good. That's what it is. Yeah. So yeah, and so that's one thing. That's why that matrix is so useful because that's where we're going to get to in time. When that time is, as quickly as possible. How quickly do we want to get there? Well, this process of design, let's get it moving real fast. Let's get the improvements happening real fast too. So yeah, we know how much the pot of gold is. How quickly we get there is the bit that we want to monitor is at least going the right way and hopefully get there quicker the better, basically. Okay, this was to do an RGCA, a reliability growth cause analysis for the bearings. We won't do it. A lot of these things you will learn by doing. I can talk here for 2 days and we can play games on a table here and it's interesting, the day goes by, but it's better to actually do a real one. When the time comes, we want to extend the life of this bearing. How do we increase reliability 5 times from what it currently is? Well, let's see what we've got to do. What process will give us 5 times more life and we can come up with solutions. So yeah, that technique is adaptable, and you will actually, as you apply it, it makes sense, and you'll dig deeper yourself to find what you need to find out when the time comes. Root cause analysis, we are not going to not use that, but we're going to do it the same way some chemicals use it. We're going to say, if we're going to apply a root cause on one problem, when I learn the answers, I want to take that solution laterally across the company. So every bearing is protected, every machine's now in a safer condition because I've learnt from the mistake of our previous failures. If we do it that way, then root cause analysis is a very powerful tool. But if all I do is fix one bearing on one machine and one shaft, I've really missed the value that RCA can give us. So in plant and equipment wellness, don't want to discount this. It's a tool, possibly a useful tool. It complements the reliability growth course analysis. This is a proactive tool. This is a reactive tool. After the problem, I then analyse. This one here is before the problem, let me imagine and prevent it. So I want to use both. Whatever helps us produce this result for the business is good. RCA has a methodology. I put this slide up to say, look, there is a technique to follow. If you already have a technique that meets that requirements, then carry on using that. If not, we also in the organisation have a technique to apply to any situation where there's an existing failure that requires investigation. There are known tools and devices and methodologies to apply, and this chart just says it's a process that we follow. We do a certain degree of analysis, we do a certain degree of brainstorming and what-if scenarios. We come up with our solutions, we implement those. You know, that methodology is already there. We're simply going to carry on and use that. So this process is now fairly common. A lot of companies are teaching this across their operations people, their maintenance people. It's no harder than using these post-it notes. It comes down to being a very visual, interactive activity. The thing that I've learnt is vital. The most important thing before going into an RCA is to have the evidence of the problem. If I have no failed bearings, if I have no failed machines, if I have no evidence of what actually happened, I can't do an RCA with confidence that I'll actually come to the right solution. If I cannot find the right pathway, then how do I know I've got the right answer? And the only way I know a pathway out of all these possible ways of arriving at a failure is by having the evidence.
I was reading this book on PM analysis, and they make the point that there are chronic problems and sporadic problems, and the sporadic ones are the ones that we solve this way.
Yes.
Because they tend to have one cause. But the chronic ones might have 5 or 6 different causes, and any one of them or any combination of them cause the problem, and we tend to never quite get rid of those because we never figure out what all the issues are, and so we just live at this sort of chronic level of problems and say, well, that's just the cost of doing business. But they say these can be solved if you're willing to dig into the physics of it and think about it.
True. Now, the sporadic problems are are typically caused by external agents. The chronic problems are the way the process operates. And the chronic problems are actually built into the process. And it's the way it will always happen because that's the process you're using. And that process is defective and weak and very highly variable. So yeah, the chronic problems are really inbuilt in the company. But we can change the process. We can improve it. We can dig in to understand why the process is doing what it's doing. And we would want to do that. And you know, there are tools to achieve that as well. So yeah, I guess at this point in time, a lot of work's been done to address the issues that are out there. The difficulty is to make companies do that work and make the change that they need to make, and then bed that in and make it the way the company runs. And that's the bit that plant wellness is focusing on? How do I make the company change to the company that needs to be doing things in a different way to produce the results that they're actually wanting? And not living with chronic problems that keep coming back, and sporadic ones on top of that that give us unknown, random factors and problems. So yeah, there's no, I guess we're confident we can address the issues. Once we have the answers, the hard part is to make them stick. Now, this entire process of this training is 10% of the solution. The hard 90% is making the changes in the companies and bedding those into place. And until that 90% is achieved, the company will never get the results at once. So we can point out what to do. We can define very clearly what is required to be done and what will happen. But that's just talk. That's just bits of paper. The doing of it, the change is required. The company's got to do that. We can guide them, we can assist them, we can KPI what they're doing. But that's the hard part. The easy part is doing analysis. The change is the hard part. And that bit the company's got to buy into. One more thing we know about events that cause problems is there's actually a sequence of things that happen. When we have a failure, there is a physical scientific cause. Physical failure explains, this material failed, this part broke. The challenge is, why did the part break? There must have been something that caused that part to break. There will be behind the scientific cause an operational cause. Bad practices, bad maintenance, misunderstandings. These errors in operations led to the physical failure event that became the breakdown. Behind the operational failures, there must have been business process failures. There must have been something in our business process that was the wrong design, no instructions, wrong instructions. So we cannot have this failure unless it was done incorrectly in the first place in its use. The business allowed the wrong things to be performed, not knowing that they were wrong, but that's beside the point. They still led to the failure. And behind all the business process failures, there must have been another level called latency. Somebody did not know the right thing to do or did not do the right thing, and as a consequence, they failed the business process. An example here is, you guys drive cars. How many of you speed? Me too. Our business process, the law is very clear. That speed sign is the limit. That's the rules. But we think, this time I can break the rule because the situation is exceptional. I'm in a hurry to get to a place, I can now speed because I'm in a hurry. The process is there, very, very clear. We have been told many times, we've passed exams and we passed the exams. So we actually choose to break the process. As a consequence, we speed. As a consequence, we have an accident and we kill somebody or we get hurt. And it was all designed not to happen. Yet, back here, our latency, our thinking, our view of the world, our values, our beliefs, our decision to this case is exceptional so I can break the rules in this case, justifies me to come right down to have an accident.
And we also think that we will reduce the probability of our own accident by avoiding becoming a bottleneck on the highway. Since everyone else is going 75, we have to go 75 to be safe.
Yes. Oh, look, we have many reasons to justify our actions. The point is, in the end, we've broken the rules, our processes that were there. And in companies, we're finding this typical regime is happening. This event is the outcome of many other things that was allowed to happen. Either because they weren't there to protect in the first place, or they were there and we said this time it's different and we can not use this decision and we'll do it our own way this time. So that's human nature. That's how we all are. We have to understand that will then lead to problems that we didn't actually want to see happen. Now with RCA, I have one thing that I've never really got satisfaction with. Here, we've got a pump set, and if the pump fails, if I go back and, in fact I did an internet survey looking for as many ways electric motors can fail, as many ways as drive couplings can fail, as many ways as wet ends can fail, and mechanical seals can fail in those wet ends. I found over 550 ways for this pump set to be failed. So if I've got a root cause analysis and I've got a failed pump set, which of those 553 actually were the root cause? I have no idea unless I have the evidence. Without that broken and failed part and pump, I have no way of knowing which pathway from these 553 was actually followed to cause this failure. And that's why I say when I do an RCA and I have no evidence, I'd rather forget about it. It's a waste of time because I don't know which path. You know, I could solve many, many problems that in fact were never problems. It won't solve the reason this one failed. So the technique, yes, it's powerful, provided we have the evidence to prove which path led to this failure. Because there are 553 ways to fail a centrifugal pump. And you've only got a team now with which path. So I'd rather be proactive. I'd rather be ahead and say, well, if there are so many ways, which of these ways will happen in my company? Because those 553 were a worldwide search across all the industry around the planet. Now in my industry, if it's a milk industry or a beer manufacturing industry or a processed chemical industry, only some of those ways would affect us. So I'm going to find the ways that will impact us and proactively prevent those would be better than waiting for things to break and then fixing things after they break. At the very least, if we can't go back and find the latent cause, at the very least we want to do one thing. We want to understand the scientific reason for the failure. What is the physics of failure that led to this to occur? Now this should... It's a failure, a very bad one unfortunately. Let me see if I can get this to come back up again.
Did he have a sign clearance 13 feet or something?
I have no idea. You know, this is the question we have to ask. I think he probably died. I think he probably died in there.
Really?
I don't know. You know, that thing took the cab out and squashed the cab flat. Here, where he's driving. If we go back one more time, we obviously can investigate this. You know, we can go and walk the site, see what signs were up, see how he got into that particular track to get there in the first place, because obviously that roof is limited in height. His vehicle is well above the height that's acceptable. I better actually go into the slideshow.
It was it was carelessness on his part to some extent. You know, all truckers can't use GPSs for the most part. Because GPSs will not tell you where the low clearance bridges are. And you can drive 5 miles down this road and all of a sudden not be able to get under this and have to back out with an 18-wheeler.
Yeah, that's not so easy. Yeah. What we're saying here is, look, this is obviously a disastrous situation. Probably the guy who lost his life more than likely. No, this is just an internet. I just searching for failure situations. I use this in my RCA training course. And what I'm saying is, if we can never get back to understand why this actually happened, at the very least what we can do is have a look at the physics of failure of this. We notice here, the column, it's hit the roof, the column has begun to fall away. There is no supports, there's no structure holding this column in place. This is a freestanding roof on a brick pillar. So the reason this roof fell is because it was hit, the columns tilt because there's nothing holding the columns in place, the column tumbles, and of course the vehicle gets crushed. So if I've got to solve this problem and prevent it again, because this might be the first incident in a fuel station, and I've got 100 of these fuel stations designed across the whole country. So this is one risk in one station, and there are hundreds of these across the country. I'm at risk of this happening again in every other station. So if I can't understand what led to this, at least I can understand the physics of failure and say, you know what, we've got to change these columns to steel columns, bolted down to decent foundations, so when he hits this, We actually bend the column over and not crush the vehicle. So I can come up with
You have to raise the roof.
whole lot of things we can do. You know, there's the point being is if I can't go back and find the latent cause, if I can't find out why he thought it was okay to drive there and take that risk, and I'll never know if the guy cannot be interviewed.
He was texting.
Lots of possibilities. Without the evidence, we'll never know the truth. What we do know is the structure is a lousy structure for that situation. So I'd rather have built a steel structure with bolted connections, proper foundations, pull down on bolts, so I snap off the bolts and that column bends, but the roof does not come down. Now that would have been a better solution. So yeah, from going only to the point of solving the physical scientific reason of failure, that would give us a better solution than living with what we've currently got. Yeah, it's an interesting one, that one there. Asset management. Asset management is what plant wellness is all about. Asset management across the life cycle. This particular definition comes out of PAS 55, and this is a European standard that will soon become ISO 55000. It's on its way in about, I think, 3 years' time. This proposal will become an international standard. And this is what it says that asset management is all about. Systematic and coordinated activities and practices through which an organisation optimally manages its assets and their associated performance, risks and expenditures over the life cycle for the purpose of achieving its organisational strategic plan. So asset management are activities and practices that optimise the organisation's performance done over the life cycle to manage the risk and expenditure of that business. And it is an organisational plan to achieve that. So Planet Equipment Wellness fits very well as a tool to deliver that entire intention of that requirement. So it's going to be about people and methodologies and processes that we use, and do they actually produce successful asset management? Because if it is not successful, then it's because we're doing the wrong things in the wrong way. And we've got to recognise that and change to the right ways. So these failures here don't have to happen. No? With these bearing failures, there are reasons for those. Spalling here is because there must have been a very high intense stress in a localised area. Here, this bearing here, this is a radial bearing. It's a cylindrical roller bearing. It's designed to take a radial load only. But it's getting an axial load. From somewhere, this shiny surface here, it's getting a load sideways, never designed to take that load. So I want my guys, when they maintain this plant, to say, hey, guess what? This is getting an axial load from somewhere. Let me investigate why it's happening and fix it. So when I rebuild this machine, I've solved that problem. These are the outcomes of failed business processes, failed operating processes, failed maintenance processes. If this happens in a business, the business has done something wrong. These things are not meant to happen, not designed to happen. It's because they've been allowed to happen or caused to happen. And we want to find the causes and prevent them arising in the first place. It becomes now important to understand what our machines are telling us. Now, yesterday we saw this cylinder here, this wear mark where the spool piece jammed against the side wall. 18, 16, 13 ISO count isn't clean enough. Now, at that level there, I will have to expect occasional failures of my parts because the rubbish and muck will jam together and cause those failures. I've got to be down at least 14, and 12 is better by far. So if I'm getting this result from my laboratory analysis, it's not good enough. I have to expect failure, and when that finally happens, don't get too upset because it was going to happen anyway. The fact that this particular problem cost 2 months downtime and $25 million for this company, hope they can afford it. Hope they can afford to lose that sort of money and that sort of production. When it comes to tolerance and fits of bearings, and an IT7 tolerance and fit will lead to bearing failures. I've got to be better than IT5. If I don't know what IT5 means, then I have to educate guys to understand what that means. So yeah, our 3 T's is all about understanding what is the danger point when things start going badly wrong. At this point, we're going to have what the OEM requires. What the OEM requires is that is still a problem. We want to be down here at the world's best. What is the world's best target for lubrication? Well, 12 would be a good place to start. 14 would be my middle ground, would be better, and good enough, which isn't good enough, is going to be what the OEM requires. But I've got to start with something that people will accept. And most companies and most managers will accept what the OEM recommends. Though me as an engineer looking for reliability improvement, I know that OEM requirements are nowhere near good enough. So one of the things we're going to have to teach our people is to read the machine health through the measurements they take, through the KPIs they put in place to monitor the processes they're using. And if I can't read my machine health, then I have no way of knowing its condition. So we want to stop these problems. We know what to do. Precision maintenance is part of the solution. Monitoring condition of our parts environment, of their parts stress, is part of the solution. So I'm pretty confident that we can give companies some good ways of solving their problems. We can give them the answers. We can even tell them exactly what to do and where to go to find the requirements they need to put in place. What we can't do is make them make that change. We can talk about how much money is there on the table to be won back, but if they have to train their guys to read how their machine health is, if they're going to talk about filtering all the oil out and balancing their machines properly, oh gee, that's expensive, and we can't afford to do that, well then, I'm sorry, we can show you what to do, but we can't make you do that. So that'll be our challenge in delivering these sort of solutions. We can very clearly point out the right things to do, but now we have to help them take that leap of faith to do the right things and believe that in doing the right things, in preventing unbalance, in removing contamination, in ensuring correct fastening and paying the money to do that right, will produce great results. We want to make them see the steps they need to do to produce a process that's in control and capable. And we want to help them make that change, because until they do these things, they can never get the improvement they actually would like to have. So, touched on this yesterday, the 14 steps in precision maintenance thinking. We want people to adopt these 14 things, build those into our processes of maintaining plant, of operating plant, and by doing laser aligning, and by ensuring our shafts and couplings and bearings run true, and by ensuring our machine is distortion free, by doing those, we will produce reliability. But until we do those, we cannot get reliability. So yes, here are the answers. Do these things and you'll get better results, but you've got to do them. I can just talk about it.
Is it right to think that in precision maintenance, your target is not to restore a piece of equipment to the OEM conditions, it's to make it better?
Yep. That's exactly what this is about. The OEM condition is here, and it isn't high reliability. It isn't as good as it could be. It's what someone chose as acceptable enough. We can do much better, and the world's best are there already. The Toyotas, the DuPonts of the world, the guys that are at the leading edge of asset management, they've gone there. They're waiting for us. That's where they are now, because they can do it. It isn't a hard thing to do, but it's a new process. It's a change, and you've got to make that change. What we found when we start doing precision maintenance, there's some real cost benefits. This is a record of vibration levels in equipment. As the vibration levels come down, the cost of maintenance comes down. These are real data from the US organisations. We have tabulated information. As the vibration levels go from a bad level to a good level, the cost that we used to spend at the bad level, we reduced the cost 4 or 5 times. And this is real data that's been picked up out of industry practice of applying precision maintenance. So we know there's money there in doing things the right way. It's part of our strategies available, and there's breakdown maintenance, preventative maintenance, predictive maintenance, and now, of course, precision maintenance. Lowest cost way to run your business. But it's a higher skill level, higher understanding technically of why things fail and how to prevent that failure. But it can be done. If we can do that, then our failure rates will come down because the causes of failure are removed. Our people make a better machine, rebuild it in a better condition.
Where would predictive maintenance fall in that previous slide?
Condition monitoring. Condition monitoring is the technology of predictive maintenance. It is better than breakdown by a long way. So we want to have a mix of all these. I'm not saying just do this. It'll be a mix appropriate for that situation.
So to do precision maintenance correctly, you may have to have some condition monitoring.
Yes, and typically what you would do, that condition monitoring you would use at the end of the rebuild. This technique, precision maintenance, would have a procedure to rebuild the machine using the 3 T's in that procedure. So we're going to ensure that we're doing the right thing in the rebuild. At the very end, once we restart the machine, condition monitoring proves. Now we do a vibration analysis to prove that
The test.
it's the final.
That's T. That's the third T.
No, it's the third T is happening all the time. The test to prove that the procedure I'm using is correct. Yeah, measuring the shaft diameter is a test. Measuring the bore diameter on the housing is a test. So I'm going to have the 3 T's all the way through the rebuild procedure. That condition monitoring at the end is just to prove the whole thing came together correctly, which I expect it will do because the procedure's been followed correctly. So I'm not going to expect anything unusual. If that check shows up something unusual has happened that I didn't see myself, then my procedure has got a hole in it. I've missed something important. I've got to go back and find out what that was and improve the procedure. So yeah, we're not going to throw this away. This is valuable. Use it at the right time in the right place.
But we are going to throw away breakdown maintenance.
Only when it pays off, only when it's unimportant. And we don't want to do this as our prime strategy. We'll have breakdowns if it doesn't matter. You know, if things can break and nobody cares, don't repair it until it breaks. An example might be if I've got a pipeline. Oops, let's get a decent one. If I've got a pipeline, I've got a pressure gauge here with a valve. Now if that needle falls off, does that matter? I shut that valve and the process keeps on going. So if that pressure gauge fails, it may not be important, in which case leave it failed until the shutdown comes in 2 years' time and replace it. Or if the valve is safe enough to hold and you believe it's safe, then repair it on the breakdown. So this pressure gauge has no other use than just to look at the process, and this pressure in here I can get from a process computer, then I don't really need that one there. So I can let it break and repair it on a breakdown philosophy.
Or not repair it. Just get rid of that connection.
Why have it? Yeah? Why have something that's unimportant and now got to maintain? Yeah, that's what I'll be asking, that very same question.
If something breaks and it's not worth fixing, then why is it even there?
Yeah. Now the question is that gauge being used by the operator to run the plant? If he's running his plant off that gauge, that's now a critical piece of equipment. This cannot be wrong, this cannot be failed, because he's running his whole operation off this pressure gauge. So I've got to know the consequence and the risk to the business of this thing failing. If there's no risk, if I don't care, remove it. But if it's risk, hey, I've got to trust this thing. Is it right? Because now it's really important. So you don't know it is until you analyse the situation. You're going to have to go out there yourself as a consultant and say, Mr. Operator, what are you using this gauge for? Please show me what you're doing. Is it in your procedures? Is it in your procedure to actually go read this gauge and based upon that readout, make the adjustment? Because if he's making an adjustment and there's no procedure to use that gauge, then what the hell is he doing? Uncontrolled process.
Now, is there any reason, if you're using precision maintenance principles and some condition-based monitoring, along with it, how about preventive maintenance? Is there any place, planned shutdowns, any place for that?
Yes, there is. Yes, there is. If the risk of failure is so extreme that we cannot allow parts to get to a degraded state, then I will change the part out well before the chance of degradation even starts. Tomorrow we're going to see in day 3 there's an activity of a gearbox. a gearbox is $2,500 gearbox. Not a lot of money. The question now becomes, do I maintain that gearbox every year? Or do I just say, look, these gearboxes every 3 years, throw that out and put a brand new one in every 3 years? The fact that it can go for 10 years, could go for 10 years, but if it fails, it's a catastrophe for the business. I would rather just say, look, let's not take the risk of waiting for 10 years. Let's actually just say 3 years is enough. I'm going to put a brand new gearbox to replace this one, $2,500.
But why not do the precision maintenance on it?
Because it's not worth the money.
It might be too big of a risk.
It's not worth the money. It's not worth maintaining it. So, we're going to install it correctly with no soft foot, with shafts aligned. We're going to install that precision maintenance techniques on its installation. Once it's installed in there, won't touch it again for 3 years. And it's cheaper to do that, and every 3 years spend $2,500 than try and push it for 4 years and for 5 years when that risk begins to rise because things are getting old. And if it fails, I'm going to lose $50,000. So our risk matrix, we come back again to the risk matrix, is it worth doing preventative maintenance and replacing aging parts before the failure or wait for the failure? And the financial modelling makes it very clear what to do. This is one page, and it's a quick summary of some good thinking in the way to handle assets, particularly physical assets. What this is, it comes from a company in Australia, and it's done by a now retired guy, Max Wishaw. And Max had done 35 years in the condition monitoring field. He actually went to companies, vibration monitored the equipment, oil analysis the equipment, and over 35 years, he's learnt a few things. About 3 years ago, after he'd retired, one of the companies he'd done some business for in the past said, Max, can you come down and give us a one-page summary of your 35 years of advice? What do you suggest we do to have long, reliable machinery? So this is Max's advice after 35 years of condition monitoring. And as soon as I saw it, I thought, hey, you know what? There's something here that gels with me. He says the design has to be the right design. Begins with the right selection. So it's a life cycle requirement. He's going to say, at the very beginning, pick the stuff that can do the job. And if you got that wrong at the start, you are in trouble. There are ways to confirm we've chosen the right design because we can look at the root cause of our previous failures, can look at the specifications, engineering specs of the materials in this design to make sure that this design's materials are better than the ones we had in place before. We can do performance tests, quality control checks on that design. We can do prototypes, do some laboratory tests, do in situ trials. He says, make sure the assembly is precision assembly. Here it is, precision maintenance and alignment. Must do that to get reliability. We can check it is done correctly with our condition monitoring technologies. Must have lubrication that is in good condition. Lubrication management is a #1 requirement. This is what he's found in 35 years. Without that, you are forever in trouble. And we can confirm the lubrication is in control through our analysis of oil and quality of the chemical composition of our oils. Operation must be part of the solution. The guys must know what to do, that is the correct way to run the plant, and we must have training and upskilling of our people with the routines of maintenance to ensure that plant is properly supported. And we can confirm that through our KPIs, our monitoring with our precise checklist to monitor for. So in here was Max's 35 years of advice on one page. It's a life cycle issue, lubrication is critical, maintenance is critical, and precision maintenance is vital, and good operating practices are part of the success story. So when I came across that, and he gave that to me to say, this is what we passed on to this company, and by then I'd understood where he was coming from and seen myself that our current history of maintenance is not so good in its performance. So I put this in to say, look, these are the things that work. And we are going to do these things in plant wellness as well. And hopefully, after the end of day 2, what we've talked about over the last couple of days, this gels and says these are sensible things, and plant wellness supports every single one of these and wants this to happen in a business, because if I do this right, I will get this right result every single time. So yeah, we're heading towards the end of the afternoon. What are the magic numbers that make our machines come to this boundary here? When we're in that boundary, we will get this outcome every single time. I need a process to find those magic numbers, to make the company change, to do these things correctly, properly all the time, and I guarantee, Mr. Manager, you will get far better results and much more profit and uptime and throughput and quality and happiness in your business. What we will see in terms of the life cycle, if we simply do our current practices, if we condition monitor looking for failure, because that's what we're doing. Condition monitoring is looking for the P point that tells us failure's already started. I find the failure starting, then I maintain it before it breaks down. We're going to go to find and make sure, let's look for the health of the machine. Is the machine healthy? Because now I'm looking for the condition of health change. That wear particle count has gone above 12, that's too high. I want to bring it back down below 12 on the ISO 4406 count. So I'm going to look for the health and condition of my components, of my parts. Because I'm now looking for the beginnings of a health change as opposed to the beginnings of a failure already happening, I'm going to be proactive by several months ahead of the failure. And I should be able to see uptime improving. There'll be far less problems because I'm monitoring early on the situations that are affecting the conditions that cause failure to eventually arise. I'm going to control those conditions. So I'm going to refilter my oil very early. I'm going to check my alignment very early on before it becomes out of alignment. I'm going to do proactive things to make sure that nothing's actually changed from the conditions that create success. That's the thinking behind plant wellness. We are looking at health monitoring as opposed to failure monitoring. In terms of asset management, it's part of the solution. We're going to be doing the right things in our maintenance, in our operations, in our engineering. We're going to build the process to create a reliable plant. That process will need to be put into place and followed and practiced by the people. And if we can do all these things, and there are many things to do well, it's not an easy thing to do. If it was easy, it'd be happening right now. It's a hard thing to do, but it's the right thing to do. And if we can turn this into one only way of doing it, one best way that everybody follows, the one best way, the Boeing and the Airbus thinking, then we're going to get the results that those companies get from their aircraft reliability. So plant wellness is all about creating an environment where the plant is healthy all the time. We are doing the right things to maintain health. Wellness in human beings is sleeping well, eating well, exercising sufficiently, socialising properly, having friends, and enjoying life in the right way. That wellness idea of doing the right things proactively to our plant is what this is all about. If we do that, we're going to get great morale, top quality product, happy customers, reliability that will produce profitability for the business. Our plant operational availability is going to be high. Maintenance costs are going to come down because it won't need maintenance. Everything's healthy. So why maintain a healthy thing when it's already healthy? Our risk control is in place. Our operations are steady and stable. I can now repeat and guarantee month after month, week after week, what's going to happen in that business. So that's the big picture that we're trying to make happen in companies with one single process, the plant wellness way of deciding what to do to achieve that outcome.
Now, is that to look like a person with a head? Was that deliberately drawn?
It was put together to tie in with the PAS 55. In PAS 55, they talk about the assets of a business, and the physical assets is what PAS 55 or ISO 55000, when it eventually becomes that, is about. So we wanted to sort of bring it all together to say, well, plant wellness handles your physical assets.
I thought maybe it looked like a mannequin, sort of, because in connection with human wellness.
I like that idea. We could change that to become a human being. I like that idea.
Plant wellness is the heart.
Yeah, and morph it into a human being. The person becomes a better person and better results.
That's what I thought it was happening.
Well, I actually saw it as an umbrella. I saw it as an umbrella, and the umbrella gives us protection against disaster, and because they're not going wrong, we're getting these payoffs.
You could have an unhealthy looking torso, overweight, unhealthy, Morphing
morph it
into
across.
to Arnold Schwarzenegger.
I like that one there. Chris, can you do that for us? That was interesting. Yeah, I like that because it is about people in the end. Yeah? That 90% is a people issue.
Well, that's the whole connection of wellness that we need to get across. And we're talking about plant wellness like a human wellness. We don't wait to get sick, we try to stay well.
Yeah. And that's a complete mind change, you know, it's a complete mindset change, but it's the smart thing to do. So again, I guess some words around what we're trying to achieve in the end. It's a process for developing and combining engineering assets, the physical factors, financial objectives, the mental factors, human resources, the emotional factor of plant wellness, and organisational culture, which is the spiritual driver of a business. Sustainable, healthy, invigorating, satisfying operating performance from physical assets. So we're trying to combine the science with the people, with the business processes, with the aim of the business to achieve what we all want out of this business. And the whole point being is I don't want to have 1,000 consultants do the same thing 1,000 different ways. We want to have one process that produces the results for a business that suits that business, but only one way to work through those 6 steps. And at the end of those 6 steps is what's best for this business. And tomorrow when I do another company, what's best for that company. And next week when I do a different company, what's best for that company. Same process of analysis and decision making and selection, but the right decisions for that business in that situation.